complete?
We did complete multiplication and division and fraction.
So did you do any structured questions?
Yes.
Alright, good. So we might need to do like review, just to make sure that say, oh, we get also so yesterday.
Yeah.
So yesterday. Okay. Okay, alright, good. It's working. Now it's stink. Yeah, now it's stink. Now it's stinky mouth. Alright, beautiful. So let us review, recap. And then you guys did decimals already.
Yes, sir.
Alright, so the decimal class that we did last week is coming up sometime this evening.
Okay.
So I finished the it's uploading now, but we don't know what time to release it. So you can watch back that in case you miss the whole entire class is coming. Alright, so recap as usual. Let's just see from here. Alright, so recap. Let's go. So we have 3 and 2 over 5 divided by 4 and 1/3 minus 2 and 3/5. Alright? Very typical, very usual question. And then you have the ones now where you have to really use up pennies. So you have 2 and 1/9 minus 1 and 1/4, all divided by 5 plus 2 and 1/3. 3 and 1/3. So these two questions are really for review. I don't want to get too much into the fraction because like I said, only one of these questions actually come in the exam. Come with 3 marks, 2 marks. So and boom, ready? So we say top part, bottom part. The top part is 3 and 2 over 5. So there's nothing to do here except just to convert. There's nothing to do, there's nothing to add, subtract, or divide, so just do convert. 5 times 3 is 15, 15 plus 2 is 17 over 5. You put a little box around that, not mandatory, but that's just my style. Just to remind yourself that I'm coming back to that result in a second. Finally, now, you end up with something to convert as well as to subtract. So 3 fourths is 12 and 1 is 13 over 3. I'm able to take away 5 twos is 10 and 10 plus 3 is 13 again over 5. And remember, don't get distracted. Remember your rules then. Don't want to make a mistake and be like 13 minus 13 is 0. So I'm saying this. You see me, I know it's 13 over 3 minus 13 over 5. That's 2 over 5. So I'm saying no matter that. Know the rules is to find the LCM. So which is 15. 3 into 15 is 5. And 5 into 15 is 3. When you go on the calculator, 5 times 13 is 65. And 3 times 13 is 39. 3 times 13 is 39. So then we end up with, that looks like 11 and 15, that's 26. 26 over 15. Alright? Now because we're not finished with the answer, right? There's no point in converting this to a mix or converting that to a mix. Because we're not done. So we're going to have 17 over 5 divided by, hold on, yes, 17 over 5 divided by 26 over 15. And then the rules for division is that we change the division sign to multiplication. 17 over 5 and multiply that by 15 over 26. Flip it. Flip the 15 over 26. And then now we look for something to cancel out. Clearly, 17 cannot go into 26, nor is there anything that can go into 17 or 26. But 5 can cancel out itself once, and 5 into 15 is 3. So we end up with 17 times 3, which is 51, and 1 times 26, which is 26. which is our final answer. But we know so we're going to write our answer in its lowest term. Now, if instructed, do it. If not, I might give you some leniency. It's not a big deal, not a here nor there. Right, but here we end up with 1 and 25, I believe. If I'm not wrong, we get 25 over 26. And that's the solution. Okay? That's the fraction. Next one now, we have 2, so we are working out at the top, and we have something to work out at the bottom. So we proceed now, how we say A, good morning, and B. So we have 9 times 2 is 18, 18 plus 1 is 19 over 9. We take away 4 times 1 is 4, plus 1 is 5 over 4. Okay, so this is the A part. Working it out here. The LCM is going to be 36. 9 times 4 is 36. Now 9 into 36 will go approximately 4 times. And 4 into 36 will go exactly 9 times. Approximately is a wrong number. 9 into 36 exactly 4 times. 4 into 36 exactly 9 times. We proceed now, we said 4 times 19.
76.
And that's going to give us 76. And 9 times 5 is 45. So max up that now we have 15 and 20. So 5 and 26. 31?
31.
31, yeah. That's 31 over 26. Boom. That's the solution for the top. Now this one here, occasionally you might see pop up. You're working fractions, but you end up with a whole number. So for those who don't know, a whole number is a fraction. It's just that the denominator is 1. So you see this big old 5 here, it means 5 over 1. So to a fraction here, we turn everything into a fraction. So 5 over 1, this is for B part, pardon me, B part. 5 over 1, take away 3 threes is 9, oh, it's plus, thank you. 3 threes is 9, 9 plus 1 is 10 over 3. And go ahead and find the LCM. The LCM is 3. 1 into 3 times the top by 3, and 3 into 3 is 1 times the top by 1. So 5 threes is 15, and 10 times 1 is 10. So you end up with 25 over 3. And that is the solution for the second part. And so to wrap this up then, we're going to divide the top part by the bottom part. So we have 31 over 36, which is the answer for the top, and that will be divided by the answer for the bottom, which we just calculated to be 25 over 3. And then the same procedure, once again, nothing will change. Change the division sign to multiplication, and then invert the last fraction. So we have 31 over 36 multiplied by 3 over 25. And clearly, 31 and 25, well, 31 is a prime number, 25 is an odd number, they don't have anything in common to cancel. But it looks like 3 is divisible into 36. So 3 cancel out here, and 3 into 36 goes 12. So we end up then with a very simple, proper fraction. 31 times 1 is 31. And 12 times 25, I believe, is 300. 300?
Yes, sir.
300. And this here is the final result. Alright? And that would have pretty much covered the concept of fraction fraction operations, add, subtract, multiply, divide, and structured questions. Anything from here now is just coincidentally you pop up on a fraction problem. And sometimes, as I said, you can get worded questions where you have to read and interpret what they want you to do. Okay? When I can, I squeeze in a one worded problem here or there, just to keep your minds intact, right? Because not all the time, guys, you're going to get a problem like when you work, like line out, like this is what we do to get you accustomed to the procedure of solution. But generally you get like a worded problem, and it'll say something like, Anne has $500 and gave away 2/5 of her money. How much of that money did she give away? They go find 2/5 of 500, right? So stuff like that, worded questions we have to think. But we'll get to that in time, all right? But this covers the topic of fractions, and so we must move on to our second to last fundamental concept, which is percentages, right? We have ratio and proportion group. This group is doing percentages, while the other group is going to start with ratio. And when you do percentage, you want a ratio, and when they do ratio, you want the percentages, right? And so we have to do this. All right, guys. So the topic for today is going to be percentages and averages. Percentage and average. Percentage and the average. All right. Do you guys need time to take off anything? Picture, whatever you need. Alright, so the concept of fraction, just complete. No, most times when we're teaching, we teach in a sequential order. So when a topic is finished, it doesn't mean that because we say, okay, that's the end of fraction, we mean say, they're not going to meet up on some other variances of fractions. They're going to encounter fractions a lot. It's just going to be fractional calculations in a more simplified manner, right? So notice when I started, we started with operations with integers, negative and positive numbers to get everybody, understanding the perspective of that number. Then you realize that it never left you. It's just that we don't do it a lot. We don't happen to have to subtract negative from, but it will pop up now and again. We just say -3 plus 8 or 8 minus 15 now and again, right? So you use that knowledge. Then we moved on to what? We moved on to, what was it? I think we moved on to PEMDAS, and we learned that PEMDAS was the order of operations. It tells us what to do when and where. Which is what we've been doing in decimal operations, is what we've been doing in fractions. We don't left it out, it just doesn't, it's not just, like it's not out there, it's like you're not seeing that it's PEMDAS. But because you have to subtract, multiply, divide, and add, it will pop up now and again. So these are little fundamental things that it helps you to be consistent in a deep. And so we just complete fractions and we just say it's the end of fractions. But funny enough, write this down for me, a percentage, now what do I mean don't know this? A percentage is a fraction. Funny enough, a percentage is a fraction now. But guess what the difference between this now? It's a fraction whose denominator is 100. A percentage is a fraction whose denominator is 100. Which means that at all times, the denominator of a percentage is 100. It's never 200, well, at least it can be, but for the most part, when you're given the percentage, its denominator is always 100. So it's always whatever the percentage be over 100. So if I ask what is 30% of 500, it is 30% over 100. If I ask what is 15% of something, it is 15% over 100. So it's always over 100, yes? So pretty much what we do now is that we write it down like an example. Well, so percentage of fraction whose denominator is always 100. So that means 30% literally means 30 divided by 100 multiplied by whatever you're finding the percentage of, right? 10% implies 10 divided by 100. 12% implies 12 over 100. And 3% implies 3 over 100. So once you are given the percentage, once you get a problem, once you get something to calculate, and they're asking you for the percentage of an amount, you always put the percentage over 100. Okay? Right, Mama? Okay. Okay. This is why the marker and the light is affecting I always like do the talk like as I'm writing and talking, so you have to just follow my voice. Okay? So this is not about 30%. First, not difference. It is good now. Alright. Now, there's another way how you might get a percentage problem where occasionally you might have to multiply by 100. And this is when you're expressing a quantity as a percentage. So, two types of percentage questions you can get. One, you can be asked to find the value of an amount or find the percentage. Find the percentage value of an amount. And an example of when I say find the percentage value of an amount, I want to know what is the value of 30%. Let's say you have $1,000, right? Let's just make it very simple. Let's say you have $1,000, right? And you need to pay 30%. Sorry, let's not say you have $1,000. Let's say you wanted to purchase something and it cost $1,000, right? But you don't have the $1,000 to purchase the item. But there's a condition in which you can get access to this item. And it is to pay down 30% of the value of the item. If you can pay down 30% of the value of this item, you can walk out of the store with the item and then later on you pay the rest. The thing is, you can't really depend on people to tell you what that amount is because you can't do much. The 30% is any amount. So you must be able to determine that, okay, 30%, about how much that be. So when I say to you, what is 30% of 1,000, I'm trying to find out what is the value of that percentage. I'm trying to find the percentage value of the amount, right? So an example of this would be, write this down for me. So the subheading, if you want to call it a subheading, find the percentage value of an amount. That's one type of percentage problem. So a basic example of this is what is 30% of $500? What is 30% of $500? Very simple question. What is 30% of 500? I want to know, this is technically what I'm asking. I want to know how much of this $500 is 30%. Is it $30? Is it $300? Is it $200? $100? We know say 100% of 500 is 500. We know say 50% of 500, 50 is half of 100. So 50% of 500 must be half of 500, because 50 is a half of 100. And 100 is the max for percentage, right? So if I ask you for 30%, I'm asking for a little bit less than 500. How much less? I don't want this. I don't want to say it's 150 or 170 or 180. How much exactly it is? We will simply say 30 divided by 100, because a percentage is a fraction whose denom is 100. And then because you want to find out how much of 500 is 30%, you multiply it by 500. Now, 500 is a very nice number because it has a bunch of zeros, so we can do some cancellation, right? So we can say this 0, not true? Cancel this 0, not true? Or we can say this 0, cancel this 0, and then we suddenly end up that 3 times 50 is 150. So that means 30% of 500 is $150. That's what it means. We're cool, ladies? We're good? You sure? So it's all well and good when I ask you for a whole number as a percentage, but I can ask you for the percentage where it's not necessarily a whole number. I can say what is 13.5% of a certain amount. And it's the same procedure, it's just a different way of calculating. So write down example number 2 for me. This is another way where I can ask you the question. Example number 2. What is 12.5? So that is 12 and 1 over 2. What is 12.5% of $1,600? $1,600. What is 12.5% of $1,600? There's a couple ways to do this, right? There's a couple ways to do this. I'm going to show you both ways. I don't want to tell you which one I prefer, because me and you is 2 different people. Right? But I'm going to show you both ways. Watch carefully. Alright, B. So the question is, what is 16.5% of $1,600? Oh, thank you. Appreciate it. 12.5% of $1,600, right? Now, for most people that I know, everybody knows that a half is 0.5. Can I assume that everybody knows that a half is 0.5? So you're going to find a lot of persons saying, okay, 12.5 can be 12.5 over 100 multiplied by 1,600. Not sure? And then you'll find you're only the way of going around the problem. Cancel the 0 here, cancel the 0 here, cancel the 0 here, cancel the 0 here. Then go ahead and then say 12.5 times 16, and that I believe is 200. Verify that for me. I think it's 200. It might be.
This one.
$200. Beautiful. Easy maths. Simple. But what if I never half myself? What if I said what is 13 3/5%? What if I said something like 10 3/4%? And everybody knows that 3/4 is 0.75. The average person who don't like maths and all thinks that 3/4 is 0.75. 0.25 is 12.25% is 0.25. Or what if I come up with something random? Because I'm not saying winning, so don't believe that I'm going to give you a set problem. What if I say something like 15 2/3%? What is 2/3 is a decimal? Like on the top of your head. How much percent knows it's 0.66666666? The average man doesn't know that. So when you know that you're not going to know certain things on the top of your head, there has to be another method in which you can always resort to, just in case this happens. So I'm going to show you that method now. We just came on the topic of fractions, and we said that once you're evaluating a fraction, the moment that you see a mixed fraction, we must convert the mixed fraction to improper. That rule has not changed. Still the same. So with 12.5%, we can simply go ahead and say 2 times 12 is what? 24. 24 plus 1 is what? 25 over 2. Not sure. But here the problem we know. Because you know, realize you have 25 over 2, you're going to completely forget that it still has to go over 100. Because a percentage, remember I said 25 over 2 now, is just the conversion of the 12.5. But remember I said generally you would have put 12.5 over 100. But because you see 25 over 2, some students just automatically go ahead and it's multiplied by 1600 and completely forget that it has to still be divided by 100. So this is what I'm emphasizing. If you choose this method and you convert mixed fraction to an improper fraction, do not forget to put it back over 100. See? Now, all of a sudden, this must just look like something that I've never seen before. I don't know how this fraction look. You never have something over something over something. That's not normal, right? But this approach now, watch now. What do we call the numbers at the bottom of a fraction? Denominator, right? So, do you all agree that 2 is a denominator? 25 over 2, do you agree that 2 is a denominator? And do you also agree that the 100 is a denominator? So, we can make them common denominators. Not sure? So we can take that 2 here and swing it down here so. And stay so. 25 over 200. Not sure? Let us see if we're going to get the same answer. So 25, I will just carry this 2, come all the way down here, merge it with the 100, I will end up with 200 instead.
So,
yes.
and you carry it down. You got the multiply.
Yes, that's correct. So you carry it down, because what you stand on, let me show you how everything we learn is happening right in front of you. 25 over 2 over 100 is the same thing as 25 over 2 divided by 100. So what happens when you have divide fractions? You say 25 over 2, not sure, multiplied by 1 over what? 100. So see why it can become 25 over 200? I see in fraction and it just don't look like it, just I'm telling you the shortcut. So this is why we can carry this 2, come down here and make it into a common denominator. See? So yeah, 25 over 200 times what? 1600. 0 cancel 0, 0 cancel 0, 2 into itself 1 time, 2 into 16, 8, 25 times 8 is 200. Answer.
So when you put separate by that first, you
So, you know, times by 16. And so 25 by 2. Or you use the fraction bar?
Yeah.
25 divided by 2. 2? Listen. Because how I would do it, I would press this, something is 25 divided by 2, so maybe that means over 100 can be like and get 1 8. And times that one by 1600. So probably at this point you put it in the function. Okay? Alright, so we get that? Alright, so this method is effective when you can easily convert the fraction to a decimal. A half, 0.5, a quarter, 0.25, 3/4, 0.75, and something like 2/3, 0.6. So why if you don't know those decimal numbers out of your head, you have to learn the method. Now I'll show you why this method is more effective than anything else. You like this one or not? First one? The second one? First one? Alright. Try to use the first one and this one. Determine 10 and 3/5% of $520. I want to know what is 10 and 3/5% of $520. So in this case now, what is 3/5 as a decimal? You know? 3/5 as a decimal? Most people don't know that. It is 0.66 or 0.6, pardon me. So now, this is where I would then therefore run to this method. So I would therefore say 5 times 10 is 50. 50 plus 3 is what? 53. And instead of putting it over 100, we're going to put it over what? 500. Because when it was 2, it was what? 200. When it was 1, it was what? 100. So when I'm 5, you say put it over 500. And you times it by $550. See? And you begin to cancel out. If you want to cancel out, or you just want to go ahead and type that into your calculator as it is. Right? I feel at some point you're going to have to use the calculator regardless. We're not going to just do what we can do. 0 cancel 0. And I can say 2 into this is 25. And 2 into this is 26. And then I'll go on my calculator and wrap it up. What is 53 times 26 divided by 25? Ladies? Am I good? Should not get it?
Yeah.
Alright, cool. Just want to make sure.
55.12.
Pardon?
55.12.
Ms. Scott, can confirm that or somebody else?
55.12?
55.12. So $55.12. Alright? So when you get a percentage problem that's a mixed fraction, the denominator is no longer 100. The denominator is going to be whatever is at the bottom times 100. So let's say it was 11 and 2, something random. 11 and 1/8%. As opposed to say that this is over 100, you're going to say it's over 800 instead. So this bottom number will be multiplied by 100 to get you the denominator. So 11 and 1/8% of say 10 say 2,400, something like that. So what is 11 and 1/8% of 2,400?
88 over.
You're gonna say 8 times 11 is 88, plus 1 is what?
89.
89 over, instead of over 100, you can put it over what?
800.
800. Now if you want to say 80, if you want to say 89 over 8 over 100, and then drop down the 8 and it, you know, you can do that if you want to. But if you just straight with the same thing, 89 over 800 multiplied by 2,400. That's true?
Yeah.
And you go ahead and you cancel what you can cancel, however you want to cancel it. For me, it's obvious that 800 goes into itself one time, and 800 into this goes 3 times. So my final answer would be just 89 times 3. And that would be 27 and 40. That's 257.
267.
267. $267. Right? So that would be your solution. Okay?
Yeah.
So-
Over 8.
Pardon me?
In the calculator, it divides going up. But 2 by 100 and the answer.
Oh, so it do.
Divide by 25.
Oh, that makes sense. That makes sense. That makes sense. Yeah. So you see, yes, even with the calculator as an aid, if you type it in there, it will do what you have to do. So you have to know how to do it. Alright? So that's the most it can ask. It can ask you the percentage as a whole number, or it can ask the percentage as a mixed fraction. Right? And they might ask you for a decimal, but I mean, if it's a decimal, it's ABC. If I say what is 10, if I ask what is 10.3% of something, it's just 10.3 over 100 times the amount. I'm going to say. See, great?
Yes.
Alright. Obviously, I'm giving you one to try, or two to try. Alright. So find the simple percent. What is, find the value. Find the value. Find the value of percentage. One. What is 3 4/5% of 1,500? What is 3 4/5% of 1,500? This is 3 4/5, guys. 3 4/5%. 2. James donated 15% of his earnings. James donated 15% of his earnings to charity. Sorry, 50% of his earnings, which is $2,000, to charity. How much does he have left? So James donated 15% of his earnings, which is $2,000, to charity. We want to know how much money he has left after making the donation. So give that try. Done? Easy ones for the destination. Easy ones. Communicate early. As long as you have the work here to get out now, if you take them a shortcut with a block up, you'll put on the seat. This is a shortcut now. Oh, so you just use the first one? No problem.
Easier.
I don't have no problem with that. Me no want to stop it. No problem. So this time, give it the sugar. Alright. as to why I can get 15 out there. You don't know, right? You don't. Neither know. Neither know. It's cheap, 46%. But you need to figure out how we hope to stop the light from affecting the road. Lightning might be speculative. Alright. Nisha, you say, hey, come on again. This is okay. Right.
You ready for one?
No, man, it's just that I didn't see. I saw the solution, I saw the working. I saw the working, I wasn't paying attention to the solution. So it's so simple probably, then tell me why people get it wrong. It's that simple. Good job. Alright? Oh, no, are you okay? So any method you want to use, okay? Math can be done. Sorry, math is not done one way. How you feel comfortable with? I have one student in here that converted the decimal, converted the fraction to a decimal. Right? So she said 4 over 5 is 0.8. So she said 3.8 over 100 and times it by 1500. And she got 57. And the majority of you in here use method 2, where you said 5 times 3 is 15. 15 plus 4 is 19 over, well, you said 19 over 5 over 100, so that's 19 over 500, and times like 1500. And you end up with 3 numbers. Okay? No. Easy, easy. Yeah. So that's an easy finish for you. That's an easy finish. Alright? So look, that is it. Okay? No, it's the other way around now. Because later on, when you're student will complain and say, sir, when you divide by 100 again, when you multiply by 100 again, head up for me, guys. Expressing a quantity as a percentage of another. That's a subheading. Expressing a quantity as a percentage of another. Expressing a quantity as a percentage of another.
As a percentage?
Expressing a quantity as a percentage of another. So what do we mean by that? What do we mean by that? What I'm about to show you is something we do all the time. All the time you do it, you just don't know that's what you're doing. So, next week, Wednesday or Thursday? Thursday, you have an assessment, right? And on the assessment, say me give you 10 questions, right? And you get 7 right. What you're doing is that you just got 7 out of 10. So you want to know, without me telling you, you want to know how much percentage did you get? Now 10 questions, you got 7 of them right. So you're trying to express 7 as a percentage of 10. That's what you mean by expressing one quantity as a percentage of another quantity. You're trying to express the 7 you got right as a percentage of the 10 questions that you got. That's what we mean by that. And that's when we multiply by 100. Okay? So under that heading here, you say when evaluating this scenario, we multiply by 100. So it's going to be your responsibility, students, to know when you want the value of the percentage as opposed to when you're expressing a percentage as a quantity. When you're expressing a quantity as a percentage of another. It comes with experience. You do 10 questions, you do 5 of this one, 5 of that one, and after a while, so you stick as a silly question, you're going to know, okay, multiply by 100, divide by 100. Take down this example. Mary spent $210. Mary spent $210, and I'm trying to make it as realistic as possible. Okay? Mary spent $210 from her total earnings of. Mary spent $210 from her total earnings of $750. Mary spent $210 from her earnings of $750. Full stop. What percentage of her earnings did she spend? What percentage of her earnings did she spend? So it's evident, so we know how much money she spent. But we want you tell me how much she spent, but we want it as a percentage. We want you to tell me, say she spent 20%, or she spent 11%, or she spent 25%. How much of the money? So we can see it visually. Because in my mind, when you tell me say somebody spent 100% of their money, how I interpret that in my head is that they spend all their money. If you tell me say you spend 50% of the money you earn, in my mind, I'm interpreting that you spend half your money. If you tell me say you spend 10% of your money, in my mind, I'm saying, oh, I want a little chunk of money you spend. I don't know. So I want to know that the $210 that she spent out of her earnings of $750, what is that? What is the percentage equivalent of that amount? That's what the question is asking. Yes? Mm-hmm. So how we set that up now is, we go ahead now and we're expressing how much she spent compared to how much she received. How much she spent is the numerator, and how much she received is the denominator. So how much she spent is what? 210, and how much she earned is what? 750, and then we're going to multiply it by 100. And so therefore now, I don't know if you want to use cancellation or you want to use, you can use your calculator, it's up to you. At this stage here, I would have to use my calculator at some point. So I'm going to say 0, cancel 0, not true?
Yes,
and we can say, when I can do it manually, I want to practice how to work on the timetable. So I can say 5 into 10 goes what? 2 times, and we can say 5 into this goes what? 25 times. That's true? Alright. Nothing cannot go into 21, nor 25, nor 2. So we can go ahead now and I can say, alright, 210 multiplied by 2, and we divide the answer by 25. You could have just typed it in on the calculator one time and get it in, and it's done.
So
yeah.
Something wrong there.
Something wrong? I said 0, cancel 0, right?
25 times, that's what you said.
Oh, 15.
Yeah.
Correct. respect, good observation. So 0 cancel 0, and 5 into 10 twice, and 5 into 25, 15. So we can use 5 again, not sure. We can say 5 into this hour, 3, and 5 into this goes what? Yes. Oh, turn this up? Okay. Alright, so come again. So we use this 0 to cancel this 0, not sure? And then we say 5 into 10, 2 times, and 5 into 75, 15. And then we can use 5 again. 5 knock out 15, 3, and 5 into 210. How much that give us now?
42.
42? Okay, it's 42. As I say, you don't have to do this whole for cancellation. You could simply put it in the calculator like Miss Nation, and you'll say 210 times 100 and divided by 70. How much again?
84 over 3.
No, more the full answer.
Oh, divided.
Answer, yeah. So 42 times 2 divided by 3.
28.
Alright. So what that means now is that Mary, right? Mary said?
Yeah.
So Mary spent 28% of her earnings. That's what we're asking, right? So when you do things like this here, you don't have to talk about your business. You can't just say spend 28% of your money, you don't know how much is that. It does not say spend 28% of my money, no? Right, that is it. So it's just that, pick up the habit of knowing when to multiply by 100 versus when to divide by 100. Let's give you another example. Something that you encounter every day, right? Use a number like me. Let's use Nahelia's name. Nahelia, example number 2. Nahelia, Nahelia. I like to use my students as reference. Okay? Nahelia, Nahelia. Nahelia did a multiple choice exam. And she achieved 14 of 25 questions correct. And she achieved 14 of 25 questions correct. So in other words, she basically get 14 questions right out of 25. Full stop? What is Nahelia's percentage mark? What is Nahelia's percentage mark? This is something that we're going to be doing every 3 weeks. Every 3 weeks when you get the assessment, I'm not going to put the percentage on the paper because I have to give you the responsibility of checking your percentage yourself. You ask me, if you give you 20 questions, I get 11 right, and your responsibility to know how much percentage you get. That's what she got? She got 56%? Good. Alright, let us check it right now. So here's where the English comes in now. And the English language had 4 years. So we now say Nahelia got 14 questions correct out of a total of 25 questions given to her, and you times it by 100, and then work out the maths in your own way. Like Miss Nation, she just types it on the calculator and get the whole answer right, fine. Or me now, me love give myself problem. So 5 into this, 5, and 5 into this one, 20. 5 into this 1, 5 into this one, 4. Not true? So we end up with what? 14 times 4 is 56%. See that? Simple. So when it comes to percentage, that's really it, right? That's really it. And when it comes to percent, it's idea of multiplying by 100, or you're going to divide by 100. Yes, sir.
So you could use a highest common factor instead of using 5.
Could. You could. But depending on your skill, depending on the level of your timetable, it is always recommended that you use small numbers and cancel out. Because if you don't know that 25 will go into 100, right? While some person don't know that. You know 5 can go into it. So you can sit down and the smaller number gets is easier. Because you can see. Alright, so where else do you really experience percentages? Every day. Number one, when somebody gives you one discount on something. So let's say you go into a store and you're buying something. And you say, can you want to be let's say you go into a store, like Black Friday, right? And when you go into the store, you see this big red tag that says sale, 10% off. You're supposed to go into the store and know what the 10% mean. What if you go to the store and say 10% off? Let's say the item is $1,000, right? And on the tag it says 10% off. And when you got the clerk or the cashier, she take out $200 money. Now thief you want thief you.
No.
Of course a thief you.
No.
10% of 1,000 is 100.
Mm-hmm.
Oh, the rubber said. Ah, right. So it should have been the other way around. My bad, oh God. My bad. Alright, so the example I was trying to bring across was, let's say $1,000 off the item and 10% is off. So it's $100 they must take off the thing. What if you take off 50? You're supposed to address her and be like, Miss, that is incorrect. I'm not saying that's what we're going to do, you know. I'm just saying, should they do that? You should be able to say, no, that's not right. 10% of our toast is 100. Right? So if you take out 200 of those and you just walk out that store. Just walk out that store. Right? So discount is an example of percentage. Profit. When you buy and sell things. Right? Most persons when they buy anything, the objective of buying and selling is to make a profit. So in your mind you say, alright, you know what, this is how Jamaican people think. This is how people think in general. Let's say you buy something. Let's say you buy, let's say you sell clothes downtown, right? And you buy one 30 pounds, and you buy it for 30,000. It's like a bulk of pounds, 30 pounds, and it costs you 30,000. In your mind, you know, in your mind, maybe you're not doing it on paper, you know, but in your mind, you don't know what toast you pick one of your pounds. So in your mind, you say, no, I'm going to sell the pounds for 15 bills. In your mind, you know, a 5 bills you make on each pound, you know. But 30 times 5 are 15,000. So $15,000 profit you will make. But what is that profit as a percentage? How much percentage you make by your money? That's what you want to know, right? Or let's say quotes, for example. I'm not sure. Me, I have to take out things on quotes. I'm from Singer, right? Yeah, I mean, I'm not sure if you talk. You take out things on quotes or Singer, right? So when I go up there and you tell us, you know, say, if you take out this item, you can pay 15% down and take out the item. And then you continue to pay a certain amount per month. That's an example of percentage. Every day you do percentage. So discount, tax, perfect example of tax. What is Jamaica's general consumption tax value? 17 in now? I know it was 16.5, but the BS jumped to 15. I said, look.
16.5.
Nobody knows. We have to double check that. I think it's 15% now. I think they dropped the general consumption tax. Okay, in Trinidad and Tobago and in other islands, they call it VAT, value added tax. In Jamaica, we call it general consumption tax. Did you know that? Yes. Okay, good. Right? So when you go on an exam paper, yesterday we said 15% VAT and same thing as 15% GCT is the same thing. So tax, discount, well again, loans. Loans, credit cards, percentage, all of these are percentage people are using. So when you take out a credit card or you take out a loan, when you take out a loan, right, and you say, alright, you want $1 million, but the loan interest rate is 47% per annum. That means, say, you know what that means? Let us interpret. Let's say you take out $1 million, right, and Sagicor say 47%. NCB say 40%, or whatever the percentage is. What that means, you know, guys, in reality, what that means is, you see, 45% of the money that you borrowed will be added to the amount you borrow, and that you have to pay back after 1 year. That's what it means. So, if you take out a loan, so let's say you have $100,000. Let's say you take out a loan for $100,000, right? And you are supposed to pay back this loan in 1 year, but because I've already earned the money, right? And then charge you 20%. What this means, it is going to be 20% of the what? $100,000. Right? And whatever that amount becomes, cancel. So this is going to be
20,000.
20,000 this?
No, yeah.
Yeah, 20,000. So then I'm going to add the $20,000 now back on the money where you did borrow, and that's the amount that you have to pay back in 1 year. So I'm going to divide that amount by 12 and say, okay, that's the amount you must pay. That's the way. So percentage is done every day, right throughout. When you're in class, it's the same thing. Give me a time check, guys. Like, no time. 9:52. Alright, good. So that's the idea behind percentages, right? So I'm going to send you a bunch of percentage questions. I'm going to send you about 5 that is related to multiply by 100 and 5 we have divide by 100. We're going to mix them up, right? So you can have to figure them out which one you should multiply and divide by 100. Right? And then, of course, we're going to finish with percentage, right? We're going to go on to ratio and proportion. That's our next type of percentage problem as well. Alright? Alright, good job. Alright, see you guys when again? Next week Monday? Monday. Take care.
Bye, sir.
Yeah, no problem.
So the one question